All right, in chapter 6 that we're going to start today is lesson 6.1, which is graphing inequalities. And we're talking about a different type of graph than we've been doing. We've been doing slope-intercept form, standard form, point-slope form, and we've been graphing lines. But what we're going to be doing in chapter 6 is graphing inequalities. Now, if you remember, the word inequalities means the greater than sign, the less than sign. Greater than or equal to, less than or equal to. So we're going to graph these a little bit differently than we would if we were graphing on a coordinate plane. The first thing that we're going to do is if I have a greater than or less than sign, just greater than or just less than, I use an open circle. And when I'm graphing, I'm always graphing these on a number line, okay? Graphing on a number line. When I'm just solving, when I have one variable in the equation, I'm graphing it on a number line. So let's say if I had x is greater than 2, what I'd have is, let's say 2, 1, 0, 3, and 4. I would have an open circle over the 2, and since x is greater than 2, meaning x is every number larger than 2, I would just shade to the right, okay? And you can shade like this if you want. You can color in and make it really dark if you want. As long as I know, okay, their line, they are shading towards the right direction. Now, if I have x is greater than or equal to 2, okay, I'm going to do the same type of graph, but instead of an open circle over the 2, I'm going to have a closed circle. That means my x can equal to or be any number greater than 2. This one just meant it has to be bigger than 2. Okay, so you see the difference there? That's how we graph. So let's start solving some of these inequalities. Now, we solve an inequality the exact same way we would solve an equation. Nothing's different. A lot of people look at that and go, oh, I just don't know what to do. Think of it as an equal sign. It's the exact same thing. So what would I do if I wanted to get x by itself? Okay, I would just subtract 5 on both sides. And now I get x is greater than or equal to negative 2. Okay, let's graph this on a number line. Got negative 2. And remember, I always want to go smallest to biggest. Okay, I'm going to have a closed circle because it's greater than or equal to, and x is every number bigger than negative 2. So which way is that? It is this direction here. Okay, let's do this next one. What would I do to get x by itself? I would subtract 8, and I get x is greater than or equal to negative 7. So I'm going to graph this on my number line. I have negative 7. I'm going to have a closed circle because it's greater than or equal to, and I'm going to shade in every number bigger than negative 7, which is in that direction there. Okay, so let's do some more of these. So this time, I need to get m by itself, so I add 5 to both sides. I get 8 is less than m. Okay, now this trips people up when they go to graph. Okay, so let's switch it around. Let's write m is what, then 8. This is how you know you've got your sign right. Whatever is pointing to the m, see how I have the open mouth? It has to stay pointing to the m. So basically, if you flip the order, the 8 and the m, the sign has to flip also. See how we flipped the order of these right here? I flipped my sign too. So I know m is greater than 8. Okay, so let's graph this. I have an open circle because it's just greater than, and then I'm going to shade the way that all the numbers are going larger than 8. Okay, let's do the same thing on this next one. I'm going to add 4 to both sides, and I get negative 2 plus 4 is 2. 2 is greater than n. Let's flip it around so it's easier to see. N and 2. Once I flip the numbers, I've also got to flip the sign. So n is less than 2. So I have 2, 1, 3, open circle, and it's less than, so I've got to go in the direction of the numbers that are going smaller than 2. Okay? All right, let's look at this one. How would I get a by itself? Well, I asked myself, what's happening between the a and the 3? Division. So the opposite of that is multiplication. And I get a is less than or equal to 36. So let's graph this. Close circle because it's less than or equal to, and I shade in the direction that all the numbers are going less than 36. Okay? Got to get p by itself, so I multiply by 2. And I get p is less than or equal to -4. Draw my graph. And I have a closed circle because it's less than or equal to, and I want to go in the direction that the numbers are going smaller than -4. Okay, now there is one type of problem that is different. Okay, I guess I should say two types of problems that are going to be different than just solving a regular equation. Anytime at all you have to multiply or divide by a negative number, you have to flip the sign. Did everybody get that? Anytime you multiply or divide, so I've got to move a negative number to this side by multiplication or division, you have to flip your sign. So if I have to divide by 4.2, divide by -4.2, I'm going to get m. I flip my sign. It has to flip. Look what it was in the beginning. It was greater than. Now it's 6.3 divided by -4.2. And I'm going to get -0.86. Okay, so when I graph this, I'm going to do 0, 1, 2, -1. So when you graph this one, obviously I know there's not any spot for a -0.86. So we're just going to kind of put it very close to the -1. We're going to leave it an open circle, and we know m is less than, so it's every number smaller than -0.86. You're just going to have to, estimate there. Okay? Next one, I don't see a negative number, so I just divide by 2, and I get x is less than, 3. And I'm going to graph it, so I've got 3, 2, 4, open circle, and since it's less than, I'm going to shade this way. Okay, and that's how you would solve and graph inequalities.